We talk a lot about carbon fiber, but never really about how it is made. In this video, we will talk about carbon fiber, graphene, graphite, and diamond. A diamond is forever, or so they say. It's only right, however, for you to know that when you buy a diamond, you're spending thousands of euros for a few grams of carbon, the most common element in nature. I myself can tell you that carbon composes about 22% of me, and this is an enormous amount if you consider that half the weight of an adult male is water. A graphite pencil is made of carbon, just as is graphene, just as is carbon fiber as well. Therefore, what can explain such differences in these materials? A very simple thing, the structure. That is to say, how the atoms are organized in the matter. You should know that carbon is a nonmetal with an atomic number of 6. So there are 6 electrons outside a nucleus with 6 protons. This is its identity card. Electrons are fundamental to the creation of chemical bonds. In carbon, 4 of the 6 electrons can be used to form chemical bonds. So an atom of carbon can bind itself to 4 other elements, or with 4 carbon atoms. Let's take diamond as an example. Here, every carbon atom is bound to 4 carbon atoms, so that every valence electron is used in a bond. The disposition of the atoms in diamond is like that shown in the figure, and this is repeated throughout the material, creating a crystal lattice. In fact, we know that diamond is a crystalline mineral. In graphite, however, we find a different arrangement of the carbon atoms. It's also a crystalline mineral, so the structure is organized, but different. It's as though it's formed by layers, like a cake, layers which lie one above the other. Each layer is formed of carbon atoms bound together, forming hexagons, joined together like a net. In this system, every carbon atom is linked to 3 other carbon atoms, so that for each of them, 1 electron is free to move. We are speaking of an enormous number of electrons. It's as though each layer was surrounded above and below by moving electrons. The enormous difference between these 2 minerals is explained uniquely by their structures. First of all, the crystal lattice in diamond is transparent and allows light to pass through it, while the crystal lattice of graphite doesn't allow light to enter it. It's opaque. It's true that diamond is the hardest mineral there is in nature, while graphite is one of the softest. And why is this? Because, as we saw earlier, in diamond crystal, each carbon atom is locked in its position. And if the material is placed under stress, it is practically impossible for any atom to move. In the case of graphite, however, something different occurs, which depends on how the various layers we've spoken about are connected. In fact, the cloud of electrons I told you about is also responsible for the bond that holds the various layers united. So it is practically thanks to the cloud that the forces of attraction are generated, which hold the various layers united. But these forces are very, very weak compared to the bond between 1 carbon atom and another carbon atom. When graphite is placed under stress, what happens is that the layers slide with respect to one another, and this is why the material seems so very, very soft. Diamond, moreover, is an excellent insulator because there are no free electrons, since all of them are used in bonds. In graphite, however, this sea, this cloud of electrons, which is free to move, facilitates the transmission of an electric current which can happen between 2 layers. Let's hypothesize that we can isolate a single layer from the crystal that constitutes graphite. We would obtain a material with incredible characteristics. This is done only a few years ago, and the name of the material is graphene. Consider that it is the most resistant material currently known, and is practically invisible to the naked eye, because it has the depth of 1 carbon atom. But what is responsible for this great resistance? You should know that the bonds generated when carbon atoms bind themselves in hexagonal rings are among the most resistant that can be found in nature, And this also is largely due to the electron clouds which surround these bonds and practically compact and reinforce them. For now, graphene is an object of study, as are its future applications. We can hypothesize very many possible applications in the field of electronics because it is a great conductor. Thanks again to the fact that the electron cloud which surrounds it is extremely flexible and extremely resistant, and therefore it will surely be used as reinforcement for composite materials. Now let's speak about carbon fibers, which we can simply consider as being formed by sheets of graphene which are rolled or folded in a haphazard way so as to form a filament, exactly as we see in the illustration. Now, on a macroscopic scale, we can no longer speak of a crystalline structure because it is much more similar to a polymer than to a crystal. All of this confers to the carbon fiber the totality of the characteristics for which it is so well appreciated. First of all, from graphene it derives great resistance and great electrical conductivity. But with these, it combines good tenacity because the layers constitute the fiber are free to slide one relative to another if it is placed under stress. This allows carbon fiber to store energy while it is being deformed, thereby increasing its global tenacity and therefore making it so highly valued in industry. Now, I hope that it is a bit clearer how carbon fiber is formed internally, and so from where it derives all of these great characteristics that make it so highly valued in industry and in everyday life. Another thing is to understand how a small difference, for example, how atoms are oriented and organized inside materials, can generate such a number of differences, both in nature, considering the difference between diamond and graphite, as well as on the industrial level, considering the difference between graphene and a carbon fiber. I would like to leave you with a curiosity. At the beginning, we said that a diamond is forever. Well, you should know that it isn't quite so simple and lovely. In fact, both diamond and graphite are two allotropic forms of carbon, which means they are two different forms of the same element, carbon, which are both present in nature. But you should know that between the two forms, the only stable one is graphite. In other words, diamond wants to become graphite, but it can't because the atoms are blocked inside the crystal lattice. All you need to do is to take the diamond you gave your wife, heat it to 1,000 degrees Celsius in an inert atmosphere, and this will become graphite. If you like this video, I invite you to follow us on our social page. Goodbye.